Okay, I am going to try to do this online so you guys can see this. Obviously, if you have any questions, you can get a hold of me or send me an email. So to start off the notes, I'm going to click on this YouTube video of Tyler.
One of the hardest parts of being a YouTuber is doing a ton of writing. I'm constantly writing scripts. So what's a polyatomic ion?
Alright, so before we play this, he's just going to go through some stuff, and I might kind of fast forward through it a little bit. But here we go.
Well, a polyatomic ion is a group of atoms that has a charge. Here's what I mean. You probably already know that individual atoms can have a charge. They can form ions. So we can get things like Na+, Mg2+, and O2-. Polyatomic ions are what happens when more than one atom comes together and they form a big group of atoms, and then that group of atoms itself has a charge. So polyatomic ions are things like NO3, 1-, where we have one nitrogen.
Alright, so I've always said chemistry is the subject of exceptions. So we know that most things want a zero charge, but when it comes to polyatomic ions, it's this group of atoms that will combine and form together, and the electrons and the proton number and the electron number don't necessarily equal out or cancel out, so they get this charge to them. So then they become ions, and so we treat them as like an ionic bond. Now almost all of them are going to be negatives. If you see Tyler right here, most of them are negatives except for this positive ammonium. So most of the time it is going to be the second one in our formula. We know that we're always positive before we are negative. Now if I go back here, I'm going to leave, I don't know what that is, a list of these for you. This is the sheet. Now this sheet you can have out anytime. So on tests, quizzes, you can always have this sheet out. And there are two columns of them. There's polyatomic ions here and the names. Now the big thing here is we don't change the name. We will always have the name and call it the name that is on the sheet. So there's no like, instead of chlorate, it's no like chloride or anything, because we have chloride, that's just Cl. So it's always just chlorate or carbonate, not carbonide, nothing like that. So this sheet, I will get this to you, or I'll have them already handed this out to you.
And 3 oxygens, all connected together to form a group, and that whole group has a charge of 1-. Poly means many. So here, polyatomic ions, we're talking about ions that are made up of many atoms, more than one atom. Let me show you a few examples of how this actually works. So here are 2 of my favorite polyatomic ions, ammonium and carbonate. Ammonium here is made up of 1 nitrogen connected to 4 hydrogens, and carbonate is 1 carbon connected to...
So just kind of a heads up, if you can already tell, we know nitrogen is a -3 charge, and we know hydrogens are a +1 charge, if you look on your periodic table. So right now I have a -3 and a +4, and that's why it ends up with that +1 charge. And carbonate's its whole other thing, but when you start to look at electrons, because carbon doesn't have a charge on our periodic table, we know each oxygen has a -2, so it all deals with these electrons that we have floating around.
3 oxygen atoms. Now, the atoms that are in each of these polyatomic ions, they have protons and electrons in them. So what we can do for both ammonium and carbonate is we can count up the number of protons that are in each of these atoms. If I do this for ammonium, I get 11 protons. And then if I count up the total number of electrons that are in this whole group, I get 10. So these 2 numbers don't balance out. I have more protons than electrons, which means that I have more positive charge. I have a net charge of 1+ because I have 1 more proton. So my net charge here is 1+, and I can write the formula for this polyatomic ion as NH4, because I have a nitrogen and 4 hydrogens with a +1. I usually will also take the structure of this ammonium and put the whole thing in brackets and put a plus outside.
Now, we normally do not do this in chemistry in our class.
Has a positive charge. I can also call this thing a cation, a polyatomic cation, because a cation is what we call ions that have a positive charge. Now, carbonate, we can do the same thing with it. We can count up the total number of protons that are in the atoms and make it up. And we can also count up the total number of electrons that are in this whole group. We get 30 protons total and 32 electrons total. So we have more electrons than protons, which means we have more negative charge. This is going to have a net negative charge, and since there are 2 more electrons, it's going to have a net charge of -2. I can write the formula for this polyatomic ion is CO3, 2 minus, 1 carbon, 3 oxygens, total net charge of 2 minus. And then I write my structure in brackets and put a 2 minus here to show that this whole thing has a net charge of 2 minus.
Alright, so this is just explaining how we get these elements, these several elements that are together, and how they get this charge about them. Now, this is just to explain to you why this happens, but this is not anything that we necessarily need in order to do our homework or to do the test later on. So that's coming up.
We call this guy a cation because it has a positive charge, so we can call carbonate a polyatomic anion for negative ion. As I said before, there are a whole bunch of polyatomic ions. I have a small number of them on this list right here. A lot of times people ask me, they say, okay, if I knew that, say, nitrate was NO3, but I didn't know the charge, would it be possible for me to figure out the charge just on my own? And unfortunately, no. It's very difficult to figure out how many electrons a polyatomic ion has, and so you need that to figure out the charge. Polyatomic ions are really important for when you're writing chemical formulas of compounds, and since you need to use them a lot, they're one of the things in chemistry that you really just have to memorize. So I've made a video on that. It's called
Alright, so you guys will not have to memorize these. You will have that sheet that you can always have out, but what you'll find is that there are certain ones, like the more common ones, we will use them so much that you will just start to know what their charges are without me making you memorize them.
Learning polyatomic ions. If you need to learn these, which you probably do, you might want to check that video out. I talk about a number of strategies where you can that you can use to better learn these. Also, if you're interested in the actual bonding that's...
Okay, so that's what we're going to talk about is the actual bonding, so we'll stop there. So this is like why we have these. Well, if I can get... There we go. The why we have these the way they are. Alright, so if you write down what you learned from the video above, the big thing would just be is that you can have something called a polyatomic ion, which is just many atoms that bond together. We can have differing numbers of protons and electrons, which gives it a charge. Now, almost all of them are negative, except for that one positive one we saw. So this, once again, this list you will want to keep. I will have extras on the back door, but you'll probably want to keep this out. We'll be using it quite a bit. We use this even in chemistry too. We will use it. Alright, so when we name these, it's very similar to how we've named so far. We will always be positive before we're negative, so the first step right here is to name the positive ion first. So calcium, sodium, lithium, potassium, anything that has a +1, +2, or +3 charge, or if you're that one polyatomic that is on that sheet, if you are ammonia, right here, well, it's not going to let me highlight, but right here, the NH4, that would be named first. Then, just like before, we're going to name the polyatomic ion second, and I have that down as like we're naming the polyatomic second because for the most part they are negative. So, for example, if you look at this, I've got my positive first, which is just sodium. I'm not doing anything different than what I did yesterday. So that's sodium, but now when I see, hey, I've got 2 capital letters here, I'm like, that, I've got 3 elements. I've got sodium, nitrogen, and oxygen. I've got 3 capitals. So right away I'm like, oh, there's something from this sheet on here. So it's going to take some practice and some getting used to. But yesterday we would have had like NaCl, NaS, NaN, sodium nitride, or something like that, where it's just sodium and nitrogen, sodium and sulfur. Well, now I have sodium, nitrogen, and oxygen. So I'm like, okay, sodium, and then I'm going to go to this page and find NO3, which happens to be right here, and that is nitrate. So my name would be sodium nitrate. Alright, so nothing too crazy. We're just adding a little extra to this. So when we see these polyatomic ions, I'm going to go straight to that sheet, and that's how I'm going to name it. There's nothing special. I'm not having to add anything extra to this. I'm not changing the ending to the second name. And the rules from before still apply. If I had iron here, if I had iron nitrate, I would have to use a Roman numeral, right? Because iron still has that question mark. I don't know the charge. Alright, so it says, which do you think is the correct formula and why? So if you look at this, I have calcium, and then PO4. If I go to this sheet, PO4 is down here, and you'll start to know where these are. That's phosphate. So my name is calcium phosphate. So if I look at this or this one, if you guys look at these two and you think that this is the correct one, that is right. So if you look at this, it looks like I have 42 oxygen. Like that's a ton. That would mean that I have one phosphorus with somehow 42 oxygen attached to it. And that's just not something that can happen. What I can show you is that this right here will tell me that I have 2 phosphates. I have 2 PO4 molecules. If I could draw that on here, I would have a phosphorus with 4 oxygens around it, and I would do that twice. But I need something on here that I could write. But anyways, that's what it's showing me. Now this 2, it's almost like math. If it's on the outside of the parentheses, that really tells me I have 2 phosphorus and 8 oxygen. Now it only goes for what is in the parentheses, but that is what that is telling me, is that I have 2 of these phosphate molecules right here. Alright, so use your parentheses. If you don't, it will look kind of crazy like this, like 42. But what I did is calcium is a +2, so that's why I crisscrossed my 2 there. Phosphate is a -3, and I'm getting that from this paper right here. And so I crisscrossed that 3 to the calcium. So once again, nothing new as far as that goes. So let's look at the learning check. It says select the correct formula for each. Aluminum nitrate. So once again, as soon as I see that this is not ending in IDE, it's a nitrate, I know immediately that it is coming from this sheet. Now that's not always the case. For example, say I have cyanide, that ends in IDE. There's a few on here that do, but nothing. Most of them do not, like amide, and a lot of these we don't use a lot. Most of them are going to be 8s and ites, and as soon as I see that in the name, I'm going straight to that polyatomic sheet. So aluminum nitrate, aluminum is a +3. If you look at your special sheet, nitrate is a -1. So I'm going to find nitrate right here. It's NO3 with a negative sign. So it is a -1. So I'm crisscrossing again. That 1 will go to aluminum, and aluminum's +3 will go to the nitrate. So it is going to be, I about picked the wrong one. It's going to be C. Nitrate is NO3, and I crisscross that +3 down here. Copper 2 nitrate. Now remember, this Roman numeral is telling me the charge, so it's telling me that Cu is a +2, and I know that NO3 is a -1. So I'm going to be, my answer would be B. I've got Cu, my nitrate +1 got crisscrossed to the copper, my copper's +2 got crisscrossed to the nitrate. On C, iron 3 hydroxide. Now this is one that is tricky because it does end in IDE, but it comes off of this sheet. And I'm looking for hydroxide right here. It's OH with a -1. So I've got Fe, which is a +3, and I have OH, that's a -1. So iron's +3 charge, I'm going to crisscross that to the hydroxide, which would make the answer, the correct answer, C. This one is 10,4 hydroxide, so 10 is a +4, hydroxide's a -1, so I'm going to take that 4 and crisscross it to the hydroxide, which would make my correct answer A. Alright, now I'm going to match each of these names with the correct formula. So if I look at this, this is what we've been doing, MgS, and you notice I have 2 elements, and that is it. If you look at these other 2, there's 1, 2, 3, magnesium, sulfur, and oxygen on both of these. So right away I know it's coming from that special sheet. But if I have just 2, then I'm going to name it like it looks, magnesium sulfide. Now in my head, as a chemistry teacher, I'm going the whole time I'm knowing, I know magnesium's charge is a +2, I know sulfur's charge is a -2. I can look at the periodic table and find that. So I'm just going to name it magnesium sulfide. Now, if I didn't know if there was a question mark on that charge, that's when I would have to go back and figure out the charge. Same with this. If it is a polyatomic ion, I always know the charge. The sheet is telling me the charge. So this is magnesium sulfite. And if you look at SO3 on here, it is sulfite. If you look at SO4, it is sulfate, which is the next one, magnesium sulfate. Okay, once again, I'm not needing Roman numerals in my names because I know the charges of everything there. Alright, so formulas are written the same as they were before with the positive ions. I've already said that. Positive first, negative second. My charges still need to equal 0. So on this learning check, it says write the correct formula. So for instance, on potassium bromate, potassium is a K. Now it is K, it's got a +1. Bromate is going to be on the sheet. Now as soon as I see bromate, I'm like, it's on the sheet. So BrO3. And it's got a -2, so I'm going to crisscross that 2, BrO3. Now, guys, I could go on here and I could take all of these and format and do the text and do the subscript. That's going to take me some time. So what I'm going to ask is that you guys please just realize that when I write these, that they should be subscripts, okay? And I'll try to make sure we know that. All right, calcium, Ca, is a +2. I'm going to look at carbonate, and carbonate is right here. It is CO3, and it is a -2. Now, I could crisscross those and say Ca2, CO3, 2, but I'm going to simplify. If I have a +2 and a -2, they are already equal 0. Now, remember that 3 should be a subscript. All right, on C, sodium is Na, and phosphate, if you look back at this sheet, phosphate is going to be PO4, and it is a -3. So it should be Na3, PO4. So once again, I'm saying I only have one of these PO4s, but I have 3 of these. I am just crisscrossing the charges. All right, once again, the 3 and the 4 should be a subscript. Iron oxide, now this is one like we did yesterday and the day before. Iron is Fe, and it's going to be a 2 because oxide has a -2 charge, so I'm crisscrossing that. And then my oxygen is going to take that 3. I'm going to crisscross that 3 charge to my oxygen. So it should be Fe2O3. So that is one like we have done in the past. This one is a new one because I see nitrite. So I'm going to say, okay, Fe. Now, nitrite, if you check your sheet, it is NO2, I believe. Let me make sure I'm saying that right. NO2, and it is a -1. So I'm not going to put, I would crisscross a 1 here, so I'm not going to put anything at all. Now, I'm going to put parentheses on this. This would be NO3 in parentheses and then 2. I am telling you, I crisscrossed that +2 charge from my iron to the nitrate. If I don't put those parentheses there and I do this, it now looks like I have 32 oxygen. That's not okay. So that is how you go about answering these. So let me clear all of that out. Well, maybe. Oh, I'm sorry if you can hear. I've got a sick one here. Alright, so here's a few rules in your notes. When you're dealing with ionic compounds, it's always going to be your metal followed by your non-metal, right? Here's some examples of that. Here's some examples of naming them. It gives you an example of a regular naming where I don't need a Roman numeral because if I look at sodium and oxygen, I look at the periodic table and I know their charge. Here's one where I need a Roman numeral because if I look at Fe2S3, if I just said, hey, you have iron and sulfur, what's the formula? You would look up at the periodic table to crisscross and you'd be like, oh, I don't know, iron's a question mark. So that is why I have to use this formula and I have to get the Roman numeral. Here is for more than 2 elements, so that's what we were doing today. Same thing. I'm still doing the metal, the positive, and then the negative one next, so magnesium nitrate. Now, copper has a question mark. If I go look at the periodic table, there's a question mark. I don't know the charge. So I have to figure it out. And sulfate, the SO4, its charge is -2. Once again, I'm finding that from this sheet right here. If you look right here, it is -2. So I'm crisscrossing. If this is a -2, then this copper has to be a +2. That's why it's copper 2 sulfate. Now this one, this is the only one that uses that positive, ammonium. I see NH4, and right away I'm like, ooh, NH4, it is right here. It is ammonium, and it's a +1 charge. So ammonium, I know the charge, so I do not need a Roman numeral. It's just ammonium carbonate. Once again, that CO3 is coming from right here. Alright, so let's do the last learning check, and then I'll have you guys work on the worksheet, which is participation, and whatever happens, I will be there on Thursday. So we'll go over it, and I'll help you guys out if you need anything. So I'm going to name these things. This is calcium phosphate. Alright, now I know it's calcium phosphate with no Roman numeral because I know the charge of calcium is a +2 and phosphate's a -3. Got that from that sheet. Now this is going to be iron 3 bromide. Now how I can do that off the top of my head real quick is I know bromine's a -1, and I see that there are 3 of them. So my total is -3. So that's how I knew right away iron's got to be a +3. So it's going to be iron 3 bromide. C is aluminum sulfide. I do not need to do anything with Roman numerals because I know aluminum's a +3, sulfur's a -2. D is going to be manganese 2 nitrite. So I know I need a Roman numeral because Mn on the periodic table, if you look at it, you don't know a charge. You're going to have a question mark up here. So I can't just write manganese nitrate because if I did that, then if somebody would ask me to find the formula for it, I'd look up manganese and be like, ooh, I can't crisscross. So I see that nitrate is a -1 from this sheet up here, and there's 2 of them. So all together that is -2. That's how I know manganese has to be a +2. So manganese 2 nitrate. This one looks a little crazy. I have sodium, and then I'm going to say HCO3. Once again, some of this is just going to take some practice. And if I look, HCO3, you can say 2 things. You can say sodium hydrogen carbonate, or this parenthesis right here is the other name, bicarbonate. Now that's the one I use as the parenthesis because it's just a little bit quicker, a little bit easier. So my name for this would be sodium bicarbonate. Alright, this learning check. This is going to be, once again, if I write numbers, know that they're supposed to be subscript. Calcium is Ca. Nitrate, I am putting in parentheses. There's my nitrate, and I'm going to put a 2. Now I knew this right away because I know calcium's a +2 and nitrate's a -1. So I'm just crisscrossing. Same with this one. Iron, Fe, and then I'm going to put my hydroxide, which comes from that special sheet, in parentheses and put a 2. I'm crisscrossing that +2 to the hydroxide. Aluminum carbonate. That's Al2. Now I'm going to put my carbonate in parentheses, which is CO3, 3. Now the reason I did this is because aluminum is a +3, so I crisscross that to the carbonate, and my carbonate's a -2 from this sheet, and I crisscross that to the aluminum. The only time I have to use parentheses is when it's going to look like, oh, I've got 33, or I've got some crazy number here. Copper is going to be, okay, let me find hypobromide. That is one we don't use a ton. It's right here, so it's a -1, BRO -1. So I'm going to do Cu, and I'm going to do BRO. Ooh, sorry. BRO. Oh, no. O, parenthesis, and a 2. Because I need to crisscross that +2 charge to the hypobromide. And hypobromide's a -1, so there's no number I need to put there. Then I've got lithium phosphate. That is going to be Li, and that's a +1. But phosphate, if you look at your sheet, is a 3, a -3. So I'm going to crisscross that -3. And then I'm not going to put parentheses, but it's going to be PO4. Now, if you want to put parentheses, I'm not going to take points off for that. But you could leave it just like this, Li3, PO4. The only time I need parentheses is if I'm going to crisscross a number. Alright guys, that is it. I hope that you're doing okay. Like I said, if you need something, let me know, but I definitely will be back and help you guys out and go over this. It is participation, so just make sure that you've tried and that you've at least attempted to do it, okay? Put something down. Try your best. Alright, that's all I got for you.